Good morning, Exercise Science. It is Thursday, April 8th, and today we're going to continue discussing some of the functions of the blood. Just to give you a little bit of administrative stuff, Chapter 11, we'll probably conclude sometime next week. I'll probably have another lecture, maybe even two, and then conclude it with some of the assessments or assessment style questions that again are a little more creative thinking style of questions. So when we look at the blood, and again it's functionality, and you guys have done a decent job, nice job actually, of answering questions so far related to the blood, we have to look at what makes the blood functional. We talked about a little bit, I asked you about plasma proteins. We talked about the homeostatic functions of the blood and how it works. Now, what I want to talk about today are some of the cells. All right, we call these collectively formed elements. Not sure exactly where that term came from. I've never looked much into it. It sounds like a very old anatomical term, formed elements, because it doesn't really tell us anything about what we're talking about. But when we look at red blood cells, white blood cells, and platelets collectively, we call them formed elements. Now, red blood cells have a number of different names. We call them RBCs. They're also called erythrocytes. White blood cells, also called white blood cells, WBCs, and leukocytes, and platelets are also known as thrombocytes. Remember the suffix cyte, C-Y-T-E, in this case means cell. Thrombo means clot, erythro means red, and leuko means white, which makes a lot of sense. But typically what you'll see on a chart, what's the patient's RBC count, what's the patient's WBC count, platelet count, those type of things. So when we look at their basic functions, and we can get a little more detail than this, but I've just kind of put a few things up on the board. I really want you to dig into the notes on this one. There's a lot of notes in this chapter regarding the different cell types. So I just tried to cover a few basic things, so this lecture didn't last for a half hour. Red blood cells carry oxygen, right? That's their job. They use a protein called hemoglobin to do that. Hemoglobin, again, being a protein, functional, coming obviously from genetics, from DNA, to produce it. In order for it to work properly, it has to have what's called an iron cofactor. So iron is very important for the formation, or the proper formation of the protein hemoglobin. You need iron. That's why a lot of times you'll hear about people having iron deficiency anemia, which we'll talk about a little bit more in the future. Right? White blood cells, immunity. Right? They fight off pathogens. That's their job. They protect your body. And platelets are for hemostasis. We could throw the word clotting in there, but platelets typically, or specifically, don't do the clotting. The clotting involves a lot of the proteins that are found in the plasma. Platelets' job is to plug up the wound, and if you looked at the question that I asked you yesterday or the day before, you'll see that platelets' job is to form like a dam, and then in between that dam, the plasma proteins will form kind of a paste where they're going to solidify or denature the proteins within the bloodstream, turn them from liquid to solid, and then form that, what we would call, once it hardens, a scab, the clotting process, or a clot. All right, so let's go to red blood cells. There's about 4 to 6 million of these per cubic milliliter or microliter of blood. So that's a typical sample. That's a lot. That's like a drop of blood. It's small, smaller than a drop of blood. 4 to 6 million cells. All right, and white blood cells count is much lower. So I would say, just doing the math here real quickly in my head, for every 1,000 red blood cells, there's only one white blood cell. So just to understand how common they are related to red blood cells. All right, so you're much different level there. And with your platelets, they're somewhere in between, about 150,000 to 450,000 per cubic millimeter. When we look at these and what happens to them ultimately, red blood cells are destroyed at a rate of about 2 million per second. So in the time that you're going to sit here and watch this lecture, if this lecture lasts 8 minutes or so, you're going to lose close to 1 billion red blood cells in that period of time. That's a lot. So obviously, when we talk about homeostasis, if you're losing that many, the stem cells that are in your bone marrow, which I asked you a question about as well, they're going to have to crank out an equal number to keep you balanced. So that's what happens. They break down, the body wears them out. They are identified by certain cells and tissues in the spleen and the liver, and then they get broken down and recycled. Every time one dies, one has to be produced in order to maintain homeostasis, or else you'll have, obviously, different types of blood conditions, deficiencies. All right? White blood cells, many types, right? We have eosinophils, neutrophils, monocytes, B and T lymphocytes. There's a number of different types, and they have specific functions. Your neutrophils are typically what are called your first responders. They show up at the site of infection first. They're generalists. That means they're not going to be specifically looking for one type of pathogens, where your B and T lymphocytes are specific type of immune cells that are going to be looking for whatever it might be, a cold virus, cytobacterium. That's what they do. That's how they've evolved. That's their design in the body. All right, and your platelets, their lifespan's very short, less than 2 weeks typically, and again, they're broken down in the spleen and in the liver. Back to red blood cells and their functionality. What's a red blood cell do? What's it look like? Red blood cells don't have a nucleus. Right? And it's a good question to ask, and it's one that I'm going to ask on the test next week. So I'm going to let you do some digging. I'll give you some quick kind of hints as to why that is. But when red blood cells are going through their developmental phase, when they're in the bone marrow still, they are nucleated at that point. They're producing proteins. They have to build the hemoglobin. Once they're mature, they lose the nucleus. That's when they're released into the bloodstream. So if you look at a red blood cell under a microscope, you're not going to find a nucleus. And that has a few implications for the cell. A, it's not going to be able to do any type of protein synthesis. There's no DNA. There's no machinery to do that. So they're not going to be able to repair themselves. So their lifespans can be relatively short as well. Typically somewhere around 120 days for a red blood cell. And again, once they die, they just get destroyed and recycled. But I guess the question I'm going to ask you, and I'll ask you on the test, and feel free to reach out to me if you can't find this information or if you're not comfortable with the answer that you got. Well, how can a red blood cell function without a nucleus, and why? Why would we want to eliminate basically the brain or the control center of a cell that's so vital to our survival as it carries oxygen around the body? So again, this is not a deficiency. It's not a mutation that humans carry. It's very functional to lose that nucleus, and there's a reason why, and I want you to think about that a little bit. So again, look at these types of cells, go through the notes, understand them. I'll have a couple basic questions. Again, I'll somehow relate these to what you're doing in exercise science. Obviously very important to understand the delivery of oxygen, the removal of CO2 from tissues and cells as it relates to muscle function. Have a great day.